Hi, I'm Wesley Chambers from the University of Central Florida, and I had a question about the Phobos sample return mission. I was just wondering, with proximity operations, do you all plan to thrust near the surface, or what is the plan for interacting at the surface? If you could give a little more detail, maybe.
Yes, we do. So I think you're worried about the contamination, I guess. Yeah, it's a power descent, and then there's an issue about the contamination. So the way we deal with it is to arrange the angle of the thrust so that we get the minimum contamination on the samples that we're trying to collect. That's the plan. Did I answer your question, or?
Also curious about the possible kickback at all.
Possible what?
Possible kickback? Thus,
So we had a further
yes.
question about possible kickback.
Yeah, those are very, those are the kind of question that's not easy to get the immediate answer. We're working on this, and we know that they are the concerns, yes. But on the other hand, they are rather details. We haven't really gone into the detailed study on those issues yet. But we do know that there are the items that we should seriously study.
Okay, and I believe Jim Spann has a question over here.
Yes, there have been a lot of thought and a lot of discussion about going back to the surface of the moon and on an international scale, particularly the Europeans and everything. So can you comment on any of those possible mission ideas? And I know y'all really didn't discuss those, but being that we're talking about international collaborations, do you have any sense of what some of the technology challenges are that folks are looking at in terms of either a robotic mission or eventual human-landed mission, specifically addressing sample returns, whether you'd be using a deep space gateway or a platform as a caching area, and how that might involve astronauts?
Yes, me or? Okay.
Even Greg could comment if he wants to.
Go ahead. Yeah.
I'll think while you answer. So. Okay.
I was actually going to do the same. Actually, Pascal, maybe since you were addressing human concerns, would you like to start?
So, I mean, this is a big question. I'll just share with you my personal opinion. I think we should do all the above. We should go to the moon. We should go have the deep space gateway. The deep space gateway has actually not been sold very well, but I actually buy into the idea now because it's part of a well thought out logical step to get us to Mars by the mid 2030s if somehow funding stays at least what it is and ramps up a little bit by when we need it to. But what I'm trying to say here is that the deep space gateway to me is something that gets us beyond low Earth orbit and is going to be opening some options for doing more things on the moon, in cislunar space, and out to Mars. So from that standpoint, I don't think it's in competition, for example, with a return to the lunar surface. But of course, a space agency can only do so much. When I think about the return to the lunar surface, I tend to think of it as an effort that's going to be dominated by the private sector. At least on this side of the ocean, China might have a government-led program for quite a while at the surface of the moon with humans, but the private sector, I see private enterprise getting humans back to the moon, and NASA in the United States not spending a lot of tax dollars doing that. That would be my perspective on this.
I'd like to add a couple of thoughts.
Microphone's not working.
Okay.
Use the other one.
Yeah, I'll just use the other one.
No, it is. You just need to get closer.
Okay. Can you hear me now?
No.
No. How about now?
Not really.
No.
It's working. It's just really quiet.
Okay.
Yeah.
All right. I'll speak as loudly as I can, and hopefully some of it will get transmitted. One of the things that I think has really changed, Jim, in the last decade or so is is ISEC-G. And basically, for those who don't know what this is a consortium of, I believe it's 15 different space agencies around the world. It was formed after the original vision for space exploration in the early part of the last decade. And I have been involved in it. Ben Bussey, I don't know if Ben is here right now, but yeah, Ben is back there. Ben has been quite involved in it, and one of the great things that has happened. This has happened in the last year. Ben actually was one of the leaders of this effort. Is the release of a science white paper on the opportunities for science with future human exploration using the ISEC-G roadmap. So I know that that isn't a specific answer to your question. I guess that I wanted to share it though because I'm pretty optimistic that we actually have a framework now, and that with the increased possibility with the new administration. Thanks, Ricky. That's a lot better.
These are off.
Okay. All right. Anyway, with the possibilities for a return to the moon that some of us are hearing, I think that we now have the structure that took years to put into place to enable a large amount of international cooperation, and this would be done using each country's interests and expertise. So, for instance. Not to speak for you, Misaki, but Japan obviously has a great deal of experience now in sample collection from small bodies, and as well as other interests and experience as well, as do the other countries and space agencies within ISEC-G. So, Misaki, do you want to add anything?
Yes, so we are aware of the collaborative framework. We want to be a partner in that framework, of course. But at the same time, at least my institute, which is a space science institute, and it's a mixture. It's an institute mixture of a space engineering researchers, and then planetary and astrophysics scientists. So if you think about the interest of the space engineering researchers, we always want to be, something. We want to do something edgy. We want to do something that's a bit different. So we're happy to be a part of the big framework, big collaboration framework. But at the same time, we want to do something that's something only we can do, and maybe we may want to do something smaller but more frequent, small but distributed system, so that we may understand better about the surface of the moon. So something like this. There are both directions. We are happy to be a part of the framework, but at the same time, we want to be something. We want to do something that only we can do in the global landscape.
Thanks. Yes, back there.
Ariel Deutsch, Brown University. You mentioned that for the MMX mission, you were hoping to go to the surface of Phobos. So obviously, it would be really great if you could get samples from both the red and blue spectral units. And I was wondering if you will have the capability of giving multiple samples, and if not, how you will decide to give preference to which geological sampling units.
Yes, of course. It's not a requirement, but scientists' wish is to go to red unit and blue unit and get samples from each of them. And so multiple landing is in the requirement for the engineering, which puts a lot of, which requires a lot of effort in designing the landing legs. If it's only for a single, if the landing leg is used only for one-time landing, it's much simple. It is much simpler. But if you want to design a leg that allows multiple landing, you have to think about design the shock absorber in a more sophisticated way. So it is putting a lot of, it is requesting a lot of effort on the engineering side, but the requirement is that we do more than once landing on the Phobos, and it's driven by the scientists' wish that we get one sample from each of the geological unit that we already know from the from the existing data set.
I want to add a comment on this. In the 60s, when we were planning to go to the moon, there was a physicist called Tommy Gold, who was, of course, famous for predicting pulsars, who actually created a big scare because he was concerned that the lunar surface would be too fluffy and not lacking in bearing strength to support a lander. And so that, of course, prompted in part the Surveyor program to sort of test land on the moon and get a sense of the physical properties of the lunar surface. But from what we know about the surface of Phobos, I'm sort of finding myself in this odd position of feeling like I'm Tommy Gold in that regard. Okay, I'm otherwise not Tommy Gold, but in the sense that we have Arecibo radar data from Phobos and Deimos, and the Arecibo radar data are very clear. Phobos and Deimos have some of the lowest radar reflectivities of any known small body. In fact, Deimos has the lowest, and then Phobos is like up there, down there, I should say. And the predicted porosity of the regolith on Deimos and Phobos is, well, Phobos is about 40% porosity, and Deimos is 60% porosity. Now, these are huge values that you find on Earth only in freshly fallen avalanche snow. Okay, so in other words, you could be potentially looking at a really fluffy surface in the case of these moons, and so that would be a concern of mine. Now, there clearly is some strength to the surface. We see boulders, we see grooves, we see relief, we see slopes that are angle repose. So somehow things are able, the surface is strong enough to support topography. But at the same time, I think we need to really choose carefully where we land, obviously, because we could be dealing locally with terrain that is very, very soft. And then not to mention what I mentioned earlier with Mihaly's prediction of dust accumulating from Deimos onto the backside or the trailing side of Phobos. All of this adds up to some areas that we might not want to touch, basically.
Jim?
Just a comment on that. If you
Can you wait for the, yeah, she's coming. Thank you.
Jim Head, Brown University. If you interpret the grooves on Phobos as the patterns of rolling boulders across the surface, and there are plenty of boulders there in the vicinity that might support that, then it's a really good measure of the bearing strength for the near surface characteristics, and it's not the kind of 40% porosity that you would expect. That may be deeper, but the surface bearing strength, if those in fact are due to rolling boulders, is more like the lunar regolith. So it's important for all these missions to assess, that hypothesis and whether that might be an indication of how safe it is for humans.
Yeah. Yeah. Go ahead.
Hi, I'm William Yu from University of Southern California. So there's obviously some great science endeavors to go to Phobos and Deimos, but kind of looking a little further ahead in for exploration, do you see Phobos and Deimos be more integral in perhaps building an infrastructure as we're heading towards colonizing Mars? And for example, Elon Musk wants to establish Wi-Fi through satellites on Mars. Do you think private companies could perhaps have a role to play in putting their money in the game for Phobos and Deimos moving forward?
Okay, I'll take a try this. First of all, I know what Elon Musk thinks about Phobos and Deimos because I had a chance to talk to him about that. He is not interested at all in Phobos and Deimos. These are almost his words. He wants to go to Mars, and so we should go to Mars. Having said that, I personally think that we would not be worrying about Phobos and Deimos if we weren't planning on sending humans to the Martian surface. So in some sense, I really view them as an opportunity as opposed to anything that you want to sort of make specific plans around. That said, if Phobos and Deimos, for example, happen to yield water that's extractable and exploitable, then that obviously changes the whole game in the sense that all of a sudden you can have, refueling in Mars orbit and, a source of oxygen as well and hydrogen. So it's determining whether or not they contain water and how much and how deep is one of the things that we hope MMX can help us with. But it'll be central to whether or not Phobos and Deimos have a bright future down the road, I think.
Okay, back there, Paul, and then Clive.
So Paul Abel, NASA Johnson Space Center. Pascal, one of the things that I think you didn't say explicitly, but I think maybe you can expand a bit on more, is the role for humans actually returning samples from Phobos and Deimos, not only Mars, but from Phobos and Deimos itself, and the quality of the sample. And the fact that you can have humans there gives you the capability to return samples in a much more sophisticated way than we have since. In other words, we can return cold samples, keep those samples cold creation if there are any volatiles there, which we're understanding more. And that's an aspect I think that that human exploration provides us when we go to this destination and maybe others.
Yeah, that's a good point. The general thinking is that large boulders that are scattered around on the surface of Phobos or Deimos are from these bodies. Larger impactors are coming in on average at velocities that are much too high for large fragments to be well preserved over long durations. So this is sort of a rough estimate. Also, the location where you find the larger boulders on these small bodies, and this holds true for IDA, for a number of Eros, it holds true for a number of small bodies we've visited so far. The larger boulders that you find on these bodies are often associated with the largest impact structures that are on these bodies. So they will be sitting on their rims, for example. So the sense is if you actually are able to sample carefully, as Paul said, these boulders, you are likely to be sampling sort of the true nature of Phobos or Deimos. Okay? Whereas a grab bag sample from some random location is, might produce something else.
Clive.
Yeah, Clive Neal, University of Notre Dame. Don't know whether this is working. Is it working?
Yeah.
Okay, good. Question for Mario, if he can still hear us. With regard to the, you talked about the first payload to the lunar surface from in 2018, 2019. Are there any plans for future payloads? And if so, can you tell us a bit more about them?
Yes, thank you. At this point, there are no further plans for other payloads, but they will have to follow we want to think success of the first one. There are some issues to deal with, like the lunar regolith is very abrasive, and it may cause damage to the wheels or the mechanisms of the wheels. So we have to find out how to counteract that threat. At this point in time, is the first payload will be like the first test.
Thank you. Time for perhaps one more question, if there are any. It doesn't look like it, so if we could please thank our speakers again. And Mario, thank you very much for joining us remotely. We appreciate it.
Sure, thank you.
So since we had a talk cancellation, we have a little bit of extra time. What I'd like to do is reconvene for the panel at 4:20, which is about 12 minutes from now. So let's go ahead and reconvene then. Thank you. Thank you. That was good.